Hello, everyone. I hope that all participants are with us right now so that we can start with today's lecture on smart cities, the road to smart society 5.0. I will just shortly turn on my camera just to say hello, and then we can continue with camera or without, doesn't matter. I will try to actually explain why I choose this title and what was my motivation for that before we started. The main reason is because actually cities and smart cities as well are great place to combine not only engineering and technology community, but also to combine with businesses, to work together with government and to other stakeholders together. And it's actually the best place where actually innovative engineers can present their work to broader population. My motivation actually started during the pandemics, in the period when we witnessed many conspiracy theories related to virus pandemics, things about 5G, etc., etc. And then I decided actually try to actually start talking to community outside of engineering, trying to explain that actually technologies are tools in our hand to resolve some challenges and problems we face today in our world, trying to convert and improve the quality of life of regular people with some additional tools. We are trying to optimize something to be more environmental friendly, to save our time, to save money, etc., etc. So that's the reason why I just want to say that actually technologies will help us in one segment to transform our cities in better place for living, but also we want to improve our culture, actually we want to create a social impact to our communities, also to create something what I prefer to say, smart society with more responsibility and more sensitivity for many problems and challenges we are facing 21st century. So that's actually the motivation, just to try to combine multi-stakeholder point of view on one problem like smart cities. So smart cities is commonly used as some kind of buzzword today. Too many people talk about smart cities, but not only about smart cities. We are talking also about future cities, sustainable cities. When somebody talking about smart cities, you can hear that this group of people telling something about 5G, augmented reality, robotics, smart and self-driving cars, virtual reality, automatization, Internet of Things, paperless administration, smart mobility, etc., etc. So many buzzwords which actually are very common for tech community, but also you can hear that people also from business and from government sometimes using these terms. Actually, today, before we officially start talking about smart cities, I will spend some part of time to discuss about what actually means smart cities and what are goals of smart cities, but also try to demystify what really smart means, because as you can see, smart city, smart car, smart whatever, it's a very common term, but actually in current moment right now, many of solutions named smart actually means something what is not really smart, but we are using smart for marketing purposes. But actually, we want to evolve into something what is really smart. That means that we have to enable some kind of autonomy and self-regulation for the system. In this case, we are talking about cities, but we can also talk about smart grid. When we are talking about electrical grid, we can talk about smart cars. In particular, we are talking about self-driving cars, but maybe even more than that, etc., etc. So it's really, really important for beginning to understand the difference between some particular terms. So what really means smart city? I usually prefer slides without text, but I really had to do few slides with some kind of definition and introduction for smart city. And actually, I really want to try to demystify what smart city really means. Smart city uses information and communications technologies, ICT, to improve operational efficiency, share information with public, and provide better quality of government service and citizen welfare. The main goal of smart cities is to optimize city functions and promote economical growth, etc., etc. So when we are talking about smart cities, it really means that cities enhanced with information and communication technologies, solutions. Mostly, we are imagining some kind of massive sensing, collection of of those data, transfer to some data centers for segmentation, analyzing, storing, and actually mining for some deeper knowledge, which is not obvious or not possible to be understood by just human capacity. And in that meaning, I will elaborate during this lecture details on this, but actually we can agree that smart cities is something related to ICT. In these pandemic times, also we learned that it's not only important to bring a bunch of technologies in our cities, we also have to start thinking about resilience of our cities. We really need how to find a balance between technology and let's say human side of story, because otherwise we will live again in time and periods like we had during the pandemics, in the period of lockdown, where we actually not by our will, but actually we were pushed to digital transformation in super accelerating mode, without preparation for that, and that also impacted people in different way, including losing of human touch and that side of story. So it's really important to establish smart cities, to enable smart cities, to bring these services, but also to educate people, to explain people why we are doing that. And at any moment, we cannot allow that technology actually pushed us away from each other, what is really important to understand in creation of modern cities for 21st century, enhanced by technology. So there are many definitions of smart cities, but it's not about some form. We here want to talk about the purpose, about goals and vision. But just for orientation, there are few definitions, but some of them, like this from IBM, is very interesting. IBM defines a smart city as one that takes optimal use of all interconnected information available today to better understand and control its operation, optimize the use of limited resources. This is really important to understand this part, optimize the use of limited resources, because this is something what is completely aligned with sustainable development goals, with our fight against climate change, to try to, let's say, optimize costs and time in regular, everyday city operations and city services. And actually, in that way, we can improve the quality of life for citizens in one urban area today. Just for clarification, I will try to use a few examples. Just imagine public transportation. Many bigger cities have some kind of challenges to optimize public transportation and to improve quality. Also, if you invest money, if public administration, local government invest in improvement of public transportation, it usually causes the rise of prices for public transportation, what also don't make citizens happy with that. So what we can do, just imagine a situation that you can track some profiles and behavior of your citizens. If you try to track their habits about traveling inside the city. So for example, in the morning, many people traveling for the residential parts of city, to business part of city. In afternoon, people going home from business area to residentials. And if you have some special event like football match or some sport event or music concert around some stadium, for example, or some square in cities, you have increasing intensity of traveling to this particular part of cities. So if you can track that for enough period of time, and if you can profile these habits, needs, and capacities, actually you can organize your public transportation with high quality and to concentrate your vehicles in specific part of cities in the morning and opposite in afternoon. Or you can also improve capacity of specific bus, tram, subway lines in case of special events, but also during the day between morning and afternoon, during the day when most of people are in offices, you can actually decrease the number of vehicles and actually to prevent that your vehicles traveling around the city is empty, almost empty. And also, in that case, you can actually decrease the cost of operations of public transportation company in cities, and you can actually provide better service to your citizens for less money. So this is just an easy idea. You can think about that also. This is some kind of mathematical graph optimization problem where you have nodes as a bus station or tram station, and you have streets, and you can change almost in real time your lines, and you can inform your citizens using mobile application, some kind of city mobile application about the route line, the path of vehicle. So we can actually count how many people waiting on bus stations, for example, in that moment. So you can direct your vehicles to stations to pick up all people as you can in shortest period of time. So different kind of optimizations could be applied in smart cities. This is just one example in public transportation, completely basic thing, but this is the direction we want to think about, and for all people who are trying to find smart solution for smart cities, to provide some innovations and to offer something to the community. This service, for example, could be a great starting point. Also, for all people who really want to understand the global vision of smart cities, I completely recommend to find and read United Nations Agenda 2030 of Sustainable Development. And you can find 17 Sustainable Development Goals, which actually has contains vision of let's say a better world in 2050, and especially on SDG 10 on sustainable cities and communities, which is actually a little bit broader term compared to smart cities. We will talk about that a little bit later, but actually this SDG 10 contains completely smart cities, and there are some global direction what we need to provide to global community, to people around the world, that we actually can convert and transform our urban areas into smart ones. Why smart cities are important for us? Because we are facing a very accelerated process of urbanization nowadays. Actually, today, almost 50% of global population living in cities, or more than 75% of global economy coming from our cities. This process of urbanization still becomes more and more accelerated. And actually, we are expecting that in 2050, more than 75% of global population will live in cities and produce more than 90% of global wealth. So motivation for that are different, but it's mostly related to the fact that in urban areas you can provide better quality of life for you and your family. We can talk about education services, we can talk about healthcare, better opportunities for employment, etc., etc. So there are different reasons for that, but behind all of this, actually, we have a strong intensity of movement of people from rural and suburban areas to not only urban areas, but also in large cities. As a result of that, we can expect that in 2050, we will have at least 10 cities around the world with more than 50 million people, most of them in China, India, and few of them in Africa. To be honest, there are no projection that any city in Europe or North America will be bigger than 30 million, even in 2050. So when you have 50 million people, for example, living in city of Bombay in India, it's a huge challenge to provide proper sanitation, water pipelines and system at every home, public transportation, waste management. You really need to take care about enormous amount of waste, different kind of waste, from batteries for recycling to food and other organic waste. We still don't have idea how to recycle everything to use waste and convert in something useful. So this is really important to think as a potential for providing new innovative solutions. So there are huge open space for young innovative people to offer solution for that. And we really need to remember the fact that if you have 50 million people, high density in small areas, in area of one city, doesn't matter even if that city is a radius of 100 kilometers, it's still too many people in relatively small area. You need to provide all modern services which actually are deserved for citizens in 21st century. If we cannot allow, we must not allow to provide anything less than that in 21st century. So from international funds, from national funds, from local government, there are no any doubt that we will have many opportunity for funding for these kinds of solution. And this is something what we cannot avoid at all. So when we started talking about smart cities and terminology, I just said that actually United Nations Agenda 2030 has a goal 10 about sustainable cities and communities, and sustainable cities are a little bit broader than the smart cities. So if you see somewhere that somebody talking about sustainable cities, it's okay, it's still about smart cities also, but besides IoT, massive sensing, technology, mobile networks, data collection, sustainable cities also including non-tech related aspects of modern urban living, for example, city planning, more parks, more parking lots, some more space for alternative transportation like bikes or something what is actually environmental more friendly than regular cars and vehicles. But sustainable cities are also about not only technology, but also business, but also government, because when we are talking about sustainable cities, we are talking also about regulation and legislation and agile public administration, what is also very important. I'm pretty sure that many of us still have, actually still are facing many bureaucracy when we are trying to establish and found a new company, or when we need to, I don't know, do anything with government, we still need to go there to do a lot of paperwork, etc., etc. So modern, agile, and if it's possible, paperless, electronic, completely digital public administration is also the vision, broader vision of modern cities we name sustainable cities. Sometimes in some literature, by some authors, you also can find the term future cities, but in general, this is very similar to sustainable cities, and there are not too many differences in regular usage. So for readers, it's okay actually to understand that Smart cities, sustainable cities are very similar. Future cities, almost the same thing as sustainable cities. Smart cities mainly means something more tech-related. Sustainable cities is something a little bit broader term. So when we want to evaluate and to think about smart cities, we should think about these following 5 dimensions at least, not limited to. But today, smart cities, today plans, today strategies to establishing smart cities, some pilot projects around the world are mostly related to infrastructure, environment, including climate initiatives, energy efficiency, waste management, air and light pollution. What is many people don't think about light pollution, what is also a huge problem in cities. Too many public lights, 100% power during whole night. Doesn't matter there are people and vehicles or not at all. What also impacting biodiversity and impacting quality of sleep and rest for citizens, and many of us actually every day facing with that. Our problem is because we used to live with that and we will not complain, but actually that's the problem we can resolve with modern technology. Later, at the end of this lecture, I will just talk a little bit about one pilot project funded by European Union. I was the main engineer when we actually launched the pilot on 30 poles of public lights in cities with smart regulation and with huge energy savings, but not only energy savings, as I said, also trying to improve biodiversity and quality of sleep for neighboring buildings and people. So this is the second thing. After environment, we can talk about public transportation. Smart mobility is really hot topic now today. We are talking about more effective and highly functional and let's say more human-centric public transportation. Today, all cities, you can go to bus station, you can see the schedule for buses. That's okay, but it's static. It doesn't matter people need or don't need transportation. The bus will appear on this bus station at, I don't know, 2:14. We need a little bit more interaction because we have technological background right now to have bidirectional communication between public transportation system and passenger and citizens waiting for transportation. So as I already talked about one example, this is something what we can think about, but also I warmly suggest for people who are more interested in public transportation to check the hot topic smart mobility, especially because European Union funding right now many projects and solutions related to smart mobility and smart transportation, and you can see many ideas, and also you can find the call for funding for some potential research and innovative projects. Then we can talk about city planning and city plans, confident and progressive. We really need to collect some data which we can use during the city planning. We are talking completely about urban planning. We can see the and identify the spots people prefer to meet each other somewhere. Which part of city is very popular for tourism, which part of city or streets are very popular for example, for nightlife. And we can actually change and plan our city and its development and growing in that way actually to fit the real needs of citizens and their expectation. And the fifth aspect is quality of life. This is something what can or cannot be measured exactly. This is something what is subjective, how we feel actually in one city. For all of us who traveled around, sometimes you say, I'm so fall in love in Barcelona or Athena or I don't know, Belgrade, but not too many of us are able to express by words what is that. This is some kind related to quality of life. Because of something what you sometimes cannot express, you have a good feeling somewhere. For example, you are driving, so you had a great experience to find a parking lot. you didn't stack in traffic rush in some specific part of day. You experienced a great nightlife. The city is safe, etc., etc. So we can discuss about many dimensions of smart cities. But everything what I actually said can be combined in few primary and general goals. Whatever we do, doesn't matter it's related with transportation or waste management, we are actually try, number one, research usage optimization. For example, I already explained for public transportation, but for example, second example, waste management. So you can install sensors in garbage box to measure when your boxes are 80% full, and then you send signal asking for public service to send the truck to collect garbage and waste. Okay, so you will not send your trucks to garbage boxes in city blocks without real necessity. So we will change our fixed schedule for our trucks, change in something what adapting based on real needs and measurements from the field. In that case, actually, we can react in a shorter period of time to collect garbage before your box is more than 100% full, and then you have garbage around. Also, you can avoid to send your trucks, and you can actually serve city with less number of trucks, providing even better service. It's again very basic concept I'm using just for example, but it works actually. If we can resolve this kind of problem, we can save a lot of money, a lot of time for our local government, and this money can be used for some investment in some other aspects. And also, this is something what is 100% risk-free return of investment in smart services. Second thing is data-driven city planning, infrastructure, services, maintenance. When I say data-driven, data-driven means that we will collect data. This is not just our observation by eye. We will install some sensors. We will measure exactly without human influence, and we will see using different algorithms, depends on type of service, we will identify priorities in times of very limited budgets and resources we have. We want to invest in something what is number one priority, then number two priority. Doesn't matter it's observation of public administration from sensors, or actually we can also communicate with our citizens, asking some kind of feedback from them to identify what is priority for action. We also want to improve time efficiency. There are some interesting vision for smart cities named 15-minute cities. It means that actually some bigger cities, usually bigger than 2 million, but there is no some strict line what big city means. But actually the idea is to try to organize one big city into small cities, so that in walkable area of 50 minutes walking, not driving, actually you can find, if not hospital, at least ambulance, schools for education, that you can, for example, find a place for your house or flat, your residence, 15 minutes walking from your office, if it's possible. So the idea is actually to give up on the vision of residential areas and business areas of cities. Let's combine them, but not only residential and business, but also services to distribute public services, like, as I said, education, healthcare, etc. Combine that actually in the circle of 50 minutes walking, you can find everything you need to prevent and to demotivate people to using cars, even public transportation, to travel from one part city to another part city without real necessity for that. The fourth goal is cost effectiveness, what is closely related to time efficiency, data-driven planning and research usage optimization, but it's really, really important when you want to convince, especially public administration, your local public administration, that if they invest money into one of these services, that actually return of investment is risk-free, and it varies between 3 to 7 years to get your money back. But always think about that public administration, who is actually responsible to city development and quality of life, is not company. It's not about to get money as soon as possible, because we are not talking about business plan for companies, for SMEs. We are talking for business plan for public administration. For public administration, the priority goal is to improve quality of life and happiness of its citizen. So government taking care about citizens, and this is not about money. Government's always spending money, so there is no savings. It's just about how to prioritize projects and to invest into something when you can create additional savings. So next year you can reinvest some money from, for example, public transportation or waste management system into creating new garage for car, or you can create new square, or you can create new park, or some entertainment things in cities, actually improving the total image of city and quality of life, as we already discussed. And at the end of story, this collection of data and the idea to ask people for feedback, actually increasing transparency from our government, so we can be involved in decision making. We can be asked, for example, using mobile apps. You can create some kind of city mobile app as a platform for 24 hours communication between your government and citizens. You can call citizens to vote on some ideas and projects. You can also see what's going on. How many people travel by public transportations today, this week, this month, or this year? We can in real time change and publish this kind of data to be available in mobile app or city website, etc., etc. So actually, as a final result of all of this, we can say that we can increase the level of our freedom and our democratization of society. And this is the first step, what I elaborate from my title. This is first step towards smart society, actually decreasing the gap between citizens and government. Another side, we are talking about actually two stakeholders pretty separated right now. So only one thing, we have elections, so we vote, and one moment you have some new major and new local administration. But for next 4 years, usually you don't have too many interaction and opportunities to impact of city development. As I already said, what is also important for our lecture today is try to demystify the meaning of smart, not only for smart cities, but also for smart factory, for smart cars, for smart whatever. So what really means smart? And then in that moment, I really want to say one thing. Smart, I'll try to use one example before formal elaboration. Just imagine nowadays robots. So many of us thinking that robots are smart, but it's not, as well as our computers. So robots are great. So whatever we want, and if we program that robot to do something, the robot will do. Our computer will do whatever we ask from them. We will press buttons or use mouse, click on something, and our computer will do some action. But our computer cannot predict what I want to provide me something without I explicitly telling it what to do. It's the same thing with nowadays robots. So we can program a robot to take one object from point A and to move this object to point B. And we can say, robot, please do that every 30 seconds. And in that case, our robot will start doing that operation, repeating every 30 seconds. Doesn't matter what's happening around, our robot will do that action. And what could be very dangerous, for example, if in that path, robot hand using to move object from A to B, if human appear, if some engineer appear, but forget to turn off robot, you have a problem. That robot can seriously damage, injure the engineer, for example. A robot cannot understand that is not empty space anymore, and that somebody or something is in the path. In that case, the robot will still doing the operation. There is no interaction between robot and environment. There is no measurement. There is no intelligence. There is no self-regulation. Meaning smart means that actually our systems, doesn't matter we are talking about robots or we are talking about smart cities, are able to act without human explicit command, using experience based on collected data. So we are talking about artificial intelligence, deep learning. Actually, we will talk about that later also, but this is really mean to use this example to understand what the word smart really means. And when you are thinking about right now, how many people you heard smart for something, for example, smart bench, and you see smart bench with solar panel and you can charge your phone, is super nice, but I personally don't believe that this bench is still smart, because there is no any interaction between this bench and us. Maybe we can talk about green like project using solar energy is super great for environment. It's super useful that you can sit on that bench in your park to charge your phone, especially if you will spend 30 minutes there, etc. That's great. Maybe it's sustainable. Maybe it's part of future. But I'm not convinced that we are talking about smart product at all. But this kind of products could be smart if we change something on them and actually enhance them with some additional sensors and ideas. I will not provide too many ideas to you today, because actually your task is to create innovative solution. We will discuss that later, maybe in some mentorship phase, but actually this is just direction of thinking for you, and maybe in some of following opportunities to discuss, I hope we will have. We can discuss also how to convert non-smart into smart products on individual level, and then of course the whole system named smart city. It's the same thing when people talk about digitalization and digital transformation. Many of us thinking that we are talking about the same. It's not the same. Digitalization is something, for example, in public administration, if you say that your public administration is digitalized, then that's mean actually that you have a bunch of softwares and computers there. And it's nice. But if you want to be digitally transformed, it's not only about digitalization. Digital transformation contains digitalization. You need softwares, you need computers, that's okay, but also your softwares exchanging data between each other, so you don't need to type something in Word and then to type something in some database again. Your Word and your database will be connected by some specific software or API, and you will have automated synchronization between different software objects. Or even better, if you can create the huge database or databases and softwares around actually using this database as a common base of different knowledge and information. So digital transformation is also impacting change of culture of work, our expectations. We used to expect providing some services. We usually wait for a month, for example, for a response from public administration. We are expecting to get for 10 minutes, or even better, we can go directly, we can log in some public service, and we can get some kind of paper we need from public administration and bureaucracy. What was usually some kind of science fiction in the past, actually we can change and digitally transform our public administration. So behind public transformation is not only digitalization, but also it's a huge social impact implication, new business model, and new expectation. And actually, it's about decreasing the gap, for example, between public administration efficiency and business, like, let's say, objects, business institution. We have a huge gap in efficiency right now, today, everywhere in the world. So it's the same thing when we are talking about automatization and robotization on one side, and another side, cyber physical systems. Cyber physical systems are much more advanced in that meaning. They are able to safe learn, and also this is the difference between Industry 3.0 and Industry 4.0. This Industry 4.0 is combined of different cyber physical systems, and these machines can cooperate between each other. For example, two robots can help each other. One robot can ask help if it's necessary from other robot can change task, help another robot, and then when this task is done, actually both robots continue working primary tasks. Also, this cooperation can be extended to direct robot to human cooperation. In this smart environment, robots are not dangerous for people. So robot can identify if anybody of us are too close, and they will stop or slow down their operation to prevent that anybody around are injured. So from this vision, you can actually, I'm pretty sure that you are able to feel what means smart city and when do cities become smart. So we need cities to self-regulate without explicit command of people. For example, if you have sensors counting the number of passengers waiting on bus stations, in the moment when you see that you have unusually too many people waiting for buses in some specific streets, you can launch command and some kind of alert in control center and say, people, let's take 3 drivers and send 3 additional buses to this line because we have too many people waiting. We want that each of citizens can enter the bus, find place to sit to avoid standing and hanging in buses. Just we want to improve quality of life. In the moment when too many buses not necessary, some of them traveling around empty for more than 15 minutes or 30 minutes, just send 2, 3, 4 of them back to the parking lot. So if we can provide automatical reaction based on collected data and previous knowledge, then we are talking about really smart cities. For complete understanding of smart cities, it's really important to understand one general organization of smart cities, and actually there are 3 layers should be considered if we want to successfully finalize the story about smart city. It's technical. First layer is technical, and this is what engineers working on. It's about technology. It's about everything we talked until now, but also there is something after. It's operational, and it's more about business, and then you have political. You really need to convince decision makers in local government administration to say we want a smart city. It's not possible to citizens to start working on smart city. We need permission to that. We need a plan. And we will talk about that. We need actually to build some legislation, regulation, and some formalities around smart cities, because we really, citizens are very interested to be educated what is behind. For example, if you have tracker counting the number of passengers in one bus, I don't like to be identified who I am. I want to protect my privacy. I agree that number of passengers will increase for +1 when I enter, but without identification who I am. And that's the difference. And we are not talking about something we can just take as a common sense. We really need to regulate it. You need to write that in some act and say, this is the rule. You can check the number, you cannot track the people. And that's the difference. And of course, with privacy, it comes together with cybersecurity things and potential misusage and stealing our data for some bad purposes, what is not actually the goal of smart cities, but actually always when we have technology around us, we really need to take care about private cybersecurity, and in general, we need to build legislation and regulation and as a one main framework, and then in that framework, actually, we can work on our technical and operational layers. So for technical layers, it's about technologies critical for enabling smart cities. And I will just talk some basic idea and basic information of all of them, because each technology aspect is actually a lecture by itself. And we don't have time to go deeply in that, but we will try to build one broader picture. And if it's necessary, of course, later we can discuss during the questions and answers session on some specific details if some of you are interested in that. So smart cities technical layer, this is really great opportunity for innovative business models, for entrepreneurs, for innovative engineers, and everything is about data. Smart is about data, as we discussed. It's about knowledge. So knowledge is based on data. So we are talking about data-driven smart cities. When we want to collect data, we need to deploy massive sensor networks, sensing a lot of different things: triggers, counters, measurement machines for different things, like smart meters, for example, for electricity, for heat energy, whatever. And for very small amount of time, you can deploy millions, maybe even billions of sensors in some bigger cities, measuring, tracking whatever we actually want. Theoretically, that's actually something what is interesting for me. I, for example, right now in front of me, I have a smart cup. This cup is actually able to track the quantity of caffeine intake, my caffeine intake during the day. And this is something interesting. You can literally install sensors and track whatever you want in almost every device around you at your home. So this is really important to remember. It's just about if the collected data is useful or not. So we are motivated or not to do that. But technically, it's possible. And then, if you really want to have knowledge, we need artificial intelligence, machine and deep learning, and advanced mathematical algorithms from aspects of data science. And data science is something what is fundamentally aligned for everything what we name smart. We are collecting data, that means we are collecting knowledge and experience. Then we have advanced mathematical operations, what we also name artificial intelligence, machine or deep learning. We are trying some correlations, whatever, between collected data, and then we are finding knowledge. Based on that knowledge, we can actually automatize some decisions that our city can react promptly, or can help us and our experts or managers in cities to actually identify and reorder priorities depending on collected data. So the whole concept of smart cities, this technical layer is based on unity of hardware and software, and only as a whole could be understood in good way. For smart cities, the critical is to have this trilogy. Internet of Things, and Internet of Things contains massive sensor deployment for different applications. Then you have to transport this data from the physical place of collection to some data center or more data centers. So you need a strong telecommunication infrastructure. And for that purpose, actually the 5G is developed. 5G is the first mobile generation which is not developed for human-based services. So not for calls, not to increase the speed of internet access, but actually to be able to maintain connectivity to millions of different devices at the same time. It's much more difficult to maintain 1,000 connections, 1 megabit per second, compared to one connection, 1 gigabits per second. It's the same capacity, but controlling channels and different resources which should be engaged for maintaining many smaller connections, you require completely new architecture. And this is the idea of 5G. 5G is the key machine type communications enabler. And also in 6G, we are expecting that also processing power will be moved from core network to closer to base stations to access part of network, not for core, just to move processing closer to objects, because we need that for some specific applications we will discuss later, because many applications requiring very low latency and ultra reliable communications. And this is actually the way how is that going from 5G to 6G. We will discuss that later. At the end of story, we have big data. Big data is actually the whole concept of processing, storing, analyzing, segmentation, processing, and decision making based on data. We can talk about one or more data centers. In some perspective, we will talk about the centralization of our data. So if we collect the data in some specific part of the city, we will store this data next to our base station, and we will process that data next to base station, and we will create some knowledge. We will react promptly, but also later we will send this information, what we learned, to some other base station, especially to neighbor base station. Neighbor base station will rebuild their picture about what's going on and spread the news to its neighbor, and this information, this knowledge will propagate through the network. Actually, after the primary reaction, we need to have almost immediately. So data collection, data transportation, data storing and analyzing, this is the fundamental action for smart cities. And just remember, smart is always about data. This is something what is really important. Without data, without knowledge, without automatic reaction based on discovered knowledge, we cannot talk about smart whatever. Internet of Things, as I said, machine type communication, mostly machine to machine. Our sensors will report directly to some service. Massive sensing, trackers, counters, measurement station, including smart meters, applications of Internet of Things in smart cities, in smart agriculture, in smart industry also. We can install sensors on future smart car, on future robots, etc., and collect different kind of data. Depends on application and the place of application for some solution. 5G, I will not talk too much about 5G today. I will just try to direct your knowledge to proper source. Just to understand, it's not only about 5G, it's about telecommunication infrastructure in general. So we can talk about mobile networks, but also we can think about fiber optic. But fiber optic is not critical, important for some services, especially when we are talking about smart mobility. We need mobile networks for mobility, but fiber optics can be great backup for capacity and higher availability for some specific application. For example, smart metering. If you have a smart meter tracking your consumption of electrical energy next to your flat or your home, actually, the point is this smart meter will not move. So theoretically, you can connect your smart meter using fiber optics just to avoid the additional devices to your mobile network. But it's much expensive. So it depends about strategy and what you really want to do. As I said already, 5G is the first mobile generation focused on non-human centric services. And you have to remember that there are huge difference between 4G and 5G in that meaning. So further and future optimizations for mobile networks will be directed to machine type communication, non to human centric. Of course, internet speed access speed will increase for sure, but this is side effect of some, let's say, scientific achievements, not the primary goal of further evolution of mobile networks. The fundamental goal for 5G, 6G, and all future generation is to provide low latency and ultra reliable connectivity for time sensitive application. We will see later which application are time sensitive. So 5G can provide three kinds of services. When I say three kind, it's depending how we manage our resources. If we don't have something what is time critical, but asking for a huge amount of bandwidth, we are talking about enhanced mobile broadband. Theoretically, this is systems with the idea to provide fixed internet access at your home. So that means that we don't need to install fiber to the home system because it's expensive. We can actually use future 6G to provide super high internet to your access point at your home, and then you can distribute this signal to all devices, or theoretically to connect all your devices directly without access point and gateway. This vision actually means gigabytes in seconds, providing what is enabled to provide even 4K video, supporting performances necessary for gaming, etc. And theoretically, it is possible using mobile networks already with 5G and expecting to be finalized completely in 6G. Another application is ultra reliable and low latency communications, and we will see later. For example, for self-driving cars, when you have applications related to safety and human lives, all of them are asking for ultra reliable and low latency. Any mistakes are not allowed. So another mission critical application are related, for example, for modern healthcare, remote surgery. You need to have great performance of your telecommunication system if you want to provide remote surgery, and we can also discuss this kind of application. The third group of application is massive machine type communication, massive sensoring. We are talking about devices reporting just few bytes, for example, once per month, like for example, smart meters. Smart meters will just report at the end of your month, just send few bytes, just information. Okay, I'm smart meter number that this, and the value of consumption for this month is that, and that's it. But you have maybe billions of sensors in middle-sized city. So this is specific kind of application. As I said, it's very important to maintain millions of concurrent parallel connections to base station, even if 99.99% of time, all of these devices are in some kind of sleeping mode without any activities, but you need to listen permanently what's going on there. And actually smart cities are in this left lower angle of this triangle. So you can see, and actually optimization and how you organize your resources in the 5G network, you can actually provide different kind of services from this triangle, depending what is priority for your service. So this is just basic information about 5G. I will not spend too much time. What is the idea, what is different for 5G compared to previous generation? Previous generation mobile networks usually used sub-6 GHz bands only. 5G, 6G wants to expand usage of spectrum to millimeter wave from 24 GHz and above. In Europe, we will use mostly between 24 and 27. This first spectrum band you can see on this picture. It's dark blue. In United States, actually, for example, they are planning to use 71, 81, the last two millimeter wave bands you can see on this picture for some future purposes. There are many ideas to learn how to use terahertz bands, 100 and above gigahertz. You can see this is still empty. There is no idea what to do for that. But if you really want to provide super high speed, we need also to launch this part of radio frequency spectrum for some specific purposes. if you want to learn how this evolution of mobile networks is going, I completely recommend to follow 3GPP standardization institution. It's actually this institution combining experts from different vendors, from Ericsson, from Nokia, from Huawei, NEC, many of them, which actually working not only on mobile devices, what is much more obvious for regular people, but also there are many vendors for telecom equipments without products for mobile terminals, mobile phones we are using. So all of them sitting together and discussing about contribution and evolution of mobile systems. This process is permanent, so it's not that we have a 5G right now and nothing happening for years, and then we will sit for 5 years and say, okay, this is 6G. No, actually every month 3GPP has meetings from different working groups working on different aspects of mobile systems, bringing contribution almost permanently every month. And then after few years, usually after 10 years, when we actually accumulate enough innovations in mobile networks, 3GPP just declare new generation of mobile networks in one moment, but sometimes without any specific reason, just because we have enough innovations. It's already 6, 7, 10 years from the last generation. Okay, from this release, from this update of our technology, we will name this with 6G, for example. This is more marketing thing. Usually 3GPP measures expert group contributions in releases, and at least few releases are published every year. So you can see, for example, publishing of releases. The last release is, I think, 18. I have release 17 in this picture as the last presented, but I think release 18 is already published. So you can see at least once per year, sometimes even more often, we have a public release of new update in mobile networks. And as you can see, for example, this timeline for LTE for 4G, release 8 was basic LTE that was just establishing of 4G. Then release 10 we named LTE Advanced, and then release 13 Advanced Pro, and then in one moment we just decide that release 14 is not anymore LTE, it's a 5G, or how some experts name 5G is also named as new radio NR. If you see NR network, it's the same meaning of 5G, and LTE long-term evolution is the same thing as 4G. When we just remember the triangle, Internet of Things, 5G. So the last point in the triangle in Trilogy is big data. Is the place actually when we store, segment, organize, analyze, process the collected data. We are looking for some knowledge. We are looking for events. We are looking for some triggers for action. So we have a huge amount of data. From basic human logic, there is no correlation between, for example, if I'm going to restaurant 3 times during the day, if it's sunny day, and just once per day if it's, I don't know, raining day, there is no logic to have correlation between that. But if you track my behavior for enough period of time, you can, for example, find that kind of, you can identify that kind of profile of my behavior, and you can use that for prediction. And you can actually calculate some probability that I will go to restaurant 3 times today because it's sunny day. It's not 100% because it's not something what is directly causing each other, but actually you tracked my behavior for 2-3 years, and you identified that with probability 90% of more, I will do that. So maybe you can prepare some action, some different menu in the restaurant, etc., etc. So this is just a very, very naive example, but this is important to understand what is behind the term of big data. Also, your system for analyzing your mathematical operations could be supervised learning and unsupervised self-learning. So when we discuss that your system is able to train itself without human interaction, is going to be great. And at that moment, we will really start talking about smart application. What is inside big data? In big data is some kind of artificial intelligence, machine learning, and deep learning. These three terms are similar, but is the same thing like smart cities and sustainable cities. Artificial intelligence is something much broader, but with some specific constraints, more strict and more advanced. You can talk about machine learning, and with complete autonomous of data processing without any human interaction, we are talking about deep learning. And this is something what is important. Of course, for people who are more involved in data science, this is not something new, but for people who are not data scientists, just a direction for what you can Google it a little bit more, read about this, and also you can think about if you want to work on some kind of smart city applications. Maybe you need your friend or your colleague who is data scientist to be part of your team, just that you can provide this aspect of the system. We discussed about technical, so I will not spend too much time talking about operational and political. I will just try to open your eyes that you have to be aware of some other aspects of smart cities, which is not engineering related. When some of them, of course, are still engineering related. As I discussed about ultra reliable low latency communications, we are talking about standardization. Before we can provide some critical services, we really need to officially verify that your network is categorized as URLLC. Without that, you cannot provide self-driving cars on your mobile network. You cannot provide services of remote surgery. And this is important from the aspect of operations. And just to clarify how this task is complex, requirements is to provide latency less than 1 millisecond in wireless system, not in fiber optics, talking about wireless mobile network, and packet loss ratio less than 10 power on -5. Applications, vehicle to something. We discussed about self-driving car, but actually V2X system is much more than self-driving cars. We are talking about vehicle-to-vehicle communication, just to avoid collisions, for safety, just to avoid car crashes. Vehicle to pedestrians, vehicle to network, vehicle to infrastructure. You can, for example, imagine your car talking with traffic lights, and actually traffic lights are aware how many vehicles are waiting from each direction. So we can talk about optimization of traffic flow to decrease the traffic rush and to speed up transportation of people inside the city. This is, for example, basic idea. But if you really want to control your car, to be self-driving car, your car have to communicate with much more than traffic lights, with whole infrastructure and environment, plus internally sensing what's going on around, including pedestrians, and then to sometimes, if it's necessary, to decide promptly to brake, to stop, to avoid some object, just to provide extra safety for passengers, because it's about to build a trust of people into technologies. Without trust in these technologies, people will not be ready to use self-driving cars, because we still prefer it, and it's completely human thing to take a wheel in our hand, because we believe that we control our destiny with that. In this moment, you have to just sit inside and to trust that some vehicle, or almost say robot, will safely drive you from point A to point B. Also, you want to be safe that nobody will hack your car and take control of car. So we are talking about cybersecurity. We already discussed about privacy. So all of these things are very important and critical to build trust to technologies. what is in another level also critical for establishing smart cities. As I already said, telemedicine, remote surgery, this is something that already exists in some kind of experimentation phase. But the reason why we don't have this right now in operational meaning is because we don't have a telecommunication system to provide ultra reliable and low latency. This is one thing. Another thing, what is also important for this is I just discussed about maybe you remember that I discussed the accelerated urbanization, people moving from rural areas to bigger cities because, for example, hospital. Just imagine if we can provide this kind of service, we can actually, one doctor can provide service to people far away from him, from 100 or 200 kilometers. So we decreasing the number of reasons people will move to bigger cities. People will stay in small cities, in rural areas, villages, because if it's necessary, it's enough just to maybe to send the robot there and doctor can provide some surgery. This is not just about surgery. We can talk about different kind of services also, but this is just for imagination a little bit, maybe good example how we can go far. Already discussed about many applications, but this is just some picture I found with nice organization. What is inside one smart city? Smart living application, smart health, smart home, smart urban area management, smart urban planning, smart buildings. Then we have the section of smart environment. For example, waste management is part of that. Then we can talk about smart industry, smart infrastructure. For example, smart grid is great thing. It's a key enabler for renewables. You have to track the amount of energy you are getting from renewables just to be able to manage the energy, because renewables are unpredictable sources of energy. And you have to be able to keep the amount of energy constantly if it's possible. Doesn't matter what's going on with wind or sun, what impacting solar panels or wind turbines. And then, of course, smart economics, smart supply chain. Supply chain is something what becomes very critical during the pandemics that caused a lot of problems in transportation, especially in globalized world today. So blockchain applications and some sensors also can help us to track some products from the place of product creation to the final customer. Another applications, smart lighting, smart parking, smart building, smart metering, asset tracking, smart waste management. Many of these things we already talked about, so I'm pretty sure that it's clear what is our mission in the process of creating smart cities. I'm just now presenting basic examples. You can see the sensor in one parking lot. You can pay, you can see if parking lots are empty or occupied by some cars, where is the closest place for you to leave your car, etc. So this is a MBIoT based world first GPS tracker for your fleet management. Is very important for transportation companies. There are so many funny applications. For example, Track and Go by Samsonite. You can buy a baggage for your traveling, which is able actually to report their location in case that your luggage is lost or stayed at some airport. You can get information where is your luggage exactly. Smart agriculture. This is the example of applications actually developed by Huawei. You can track cows and optimize your production in agriculture. Smart meters for water pipelines and for heat energy. This is just two examples. Many of them are also, both of them are MBIoT based. This is specific low energy telecommunications technology, completely aligned and compatible with 5G and 4G. So I will not discuss about MBIoT today, but just for any of you, if you want to develop new product, MBIoT is also a great solution for the telecommunication interface. And the final part of today's lecture is this political. I will just remind you about, excuse me, about United Nations Agenda 2030 and Sustainable Development Goals. You can see the goal 11, sustainable cities and communities. This is where smart cities are located. So you can check on that, you can read the agenda, you can check on this goal specifically, and you can see actually the global vision of smart cities and urban living in the 21st century. So this is important to be aligned with these goals and visions, just because when you would like to look for funding for your projects and support, 99% of these public calls for funding, including the fundings from European Union, will be aligned with this document, with, of course, providing more details on specific application and projects. This is also about agenda. What is also important for successful story about smart cities is to apply Open Innovation 2.0 model, quadruple helix, to involve all multi-stakeholders, as we discussed in the very beginning, government, industry, academia, and civil society, what means to involve citizens in the process of prioritization and decision-making, and actually in the designing of new smart services in the cities, citizens must be involved from the very beginning. So user-centric design of service and digital only, digital by default, these two ideas should be the basic line for future design of applications. Legislation and standards also related to cities. You should take care about NIS directive, Directive on Network and Information Security, regulating everything related to cybersecurity challenges, especially we are talking about European Union and Europe in general, GDPR, data management regulation. Just be very careful if you want to collect any private data related, personally related data, when you can identify who is actually, who caused the something, who is the source of data. This is very important. Also, we are expecting right now to be adopted the Artificial Intelligence Act. If you develop any artificial intelligence in your applications, this European Union directive will ask you to register your artificial intelligence program code and to identify the level of risk, potential risk of your artificial intelligence code. And this Artificial Intelligence Act actually recognizing 4 different levels of risk based on actually related to artificial intelligence. And also there are many standards related to smart cities. You can check on IEEE, ITU, CEP, 3GPP, and ISA, OSCE, and many another international regulatory institutions, standardization institutions. You can find many recommendations, different kind of acts which actually lead lead you to proper solution, but also creating the framework, because it's not only important that your solution works, but it's also important to keep interoperability and scalability with some other vendors and service providers. Policy strategy action map. This is really the group, the set of acts you have to develop and publish before any particular action in smart city. Policy is long-term document, usually on national level. This is the general decision of your national government on the top level that if not all, but at least some of bigger cities will be transformed to smart cities in next 10 years. And we will allocate some resources, some money for that. We will support that action. Strategy is usually midterm, defining path. Okay, for this city, we have a strategy that we want, for example, improve air quality, because we have problem and challenges with air pollution. For some other cities, you have problem with waste management, etc. So each city can create its own strategy depending on real needs. An action plan is a short-term plan, very detailed, almost if not on daily basis, but on weekly basis, what we have to do from starting point to the final point if we want to develop some action of some service and actually to contribute to smart city strategy and smart city policy from what we already discussed. Also, there are many European Union related policies and legislation, maybe not so obvious related to smart cities, but containing smart cities is really important to recognize European Innovation Partnership on Smart Cities and Community. This is something what is completely related to smart cities, but also be aware of many other initiatives, regulation, vision, and policies on energy efficiency, green energy, green growth, environment, climate change, etc., and where actually your smart cities application can fit perfectly. Cohesion policy is also something what is important. So please don't think about just about smart cities. Please think about smart villages also, because cities can provide much better quality of life if we a little bit slow down urbanization process. And it's also important to keep our rural areas alive, not to create high density population urban areas. It's huge challenge to provide quality service for all of them, even in case that we have all these technologies available to help us. Also, if you want to convince your local administration to start going to smart cities, to allocate money, resources, and everything, you really need to create a sustainable business plan. You really need to discuss CapEx, cost of initial investment, OpEx, annual cost of running the maintenance, and etc. You need really to try to analyze demand, or better to say, priorities from the side of citizens, then to analyze not revenue but savings you can create using some smart city service, and then try to estimate if we launch 5 smart city services and spend this amount of money for 10 years, our total value of project of smart cities will be in positive or negative. This is MPV, and actually this is one of best measures for return of investment. This is really important to prevent, because even if you are engineers from other side, maybe they are not engineers. Usually you will talk with politicians in some cities, local public administration, and you need to convince them that if they give you some money from budget, that actually you can provide them some savings in next year and following years. What will be the biggest challenges you will face to be successful? Dunning-Kruger effect. This is just a funny part of this presentation. So you will find too many people very confident telling you that your project, your ideas, your innovations are completely bad, idiotic, whatever. But this is the same word actually Nikola Tesla heard when he actually proposed alternate currency, and you know what happened later. So don't worry. Just read, improve your experience, knowledge, and be patient, because too many people will be very negative to any change. I will just provide you one formula here. This is something what comes from Carnegie Mellon University. So if you have new idea or new proposal, new solutions, including smart city, the resistance to new idea is actually related to number of people you need to convince, with exponential on exponent of number of management levels. How many times you have to have a meeting with some institution of, I don't know, you will talk with some experts in public administration, you will talk to council, then you will talk to mayor, and you have to convince all of them, actually, not just few of them, all of them to be. And this is regular process. So I just suggest to start enjoying in process of convincing. Don't be nervous if you are not successful from the first time. Don't worry. Also, this is something about mentality, how people look to your ideas. Doesn't matter your ideas is really good or really bad, depending where you are live. The reaction of people around will be different, so don't worry about that. Also, this is something what I'm sharing from my personal experience, because the real life, the real innovation will start at the end of your comfort zone. So you don't want to going and using existing paths. You are creating new paths, a new vision, and new world. So if you want to be innovators, just to be clear, your path is difficult, and that's it. So it's not a bad idea. The path is always difficult. I will just run few slides. This is a pilot project I did in Sarajevo in Bosnia and Herzegovina. It was the part of Interreg Mediterranean project funded by European Union. We actually create smart lights on 30 poles, and we decide to change the power of lights during the day and night with some schedules. You can see here. This is winter mode. We have winter mode and summer mode. You have power 20%, 40%, up to 100%. It depends which part of day between sunset and sunrise. Actually, when your public lights are turned on, you can actually manage this. Plus, we have sensors detecting if vehicles or pedestrians appear even during the night, so we can increase from 20-30% up to 100%. Everything is depending how you program it. Of course, it could be optimized always with some additional collected data. I will just show you one slide. This is the percentage of energy, how much we save. 46% of electrical energy. We actually decreased the cost energy for public government, for local government there in this area, in this street. This is a great example how much savings we can provide if we implement the whole system for the whole city. This is just for promotion. This pilot is proof of concept idea, and we just wanted to promote actually the idea of public lights. This is just our dashboard with some additional statistics, because you always can convert your energy savings into CO2, how you save, how much CO2 actually you saved in the last 6 months, for example, etc. This is some management panels. You have exact GPS data where your smart lights are located. You have your local maps. I will just skip this part because we don't have too much time. Actually, I think I'm already above time. This is just one interesting slide. This line actually presenting the percentage of savings, and you can see each month we saved a little bit more because actually our artificial intelligence collected data, learn some new profiles and habits, and in that case, after some time, actually our savings getting better, and actually we stopped, I think, around 48%. That was stable level of savings, and that's it. Just don't remember, everything is about people, not about technology. Technology is just tool in our hand. If you think that technology can solve your problems, then you don't understand problems and you don't understand technology. It's about people. It's about our innovation, our decision making, our strong perception that smart cities are something we really need. And technology for solving many problems we already have. These technologies also already exist, but we also can ask ourselves why we don't have much more cities in the world we can name really smart. This is all about my formal presentation. Now it's time for
questions time.
Exactly. If we have some questions, I'm sorry if I was a few minutes longer than I wanted, but I hope that it wasn't boring and difficult for our attendees. So if
It's
we have
all productive. It's all productive the whole time. It's definitely a lot of information for the participants and the students to unpack. It's a lot of different projects. It's a lot of different pieces of information. It's a lot of opportunities for the students to be inspired to create their business ideas, to start innovating. So if we have any questions, now is the time to ask Mr. Maslovic. I hope I'm pronouncing that correctly.
yes.
For anyone who's a little bit more shy, and because our time is up, we have LinkedIn, Mr. Maslovic's LinkedIn account to our website, www.mindspace.gr. You can always contact him there, let him know what you need, be inspired. We love to share. We want that kind of engagement. So leave your questions in the chat room, unmute your mics, raise your hands, or you can always contact our speaker at a later date. Any questions? All right, considering the participants and the students are a little bit shy, I'm assuming it's a lot of information that they're trying to jot down and keep notes. So we'll wrap it up here. Mr. Maslovic, thank you so much for being here with us today, sharing your knowledge and your experience. We got this session. We're through it. It's over. So
I really hope that I contribute and help everybody to understand, maybe more, to inspire them to think in different directions. I shared some basic ideas. I tried to use as many examples as I can, just to, let's say, increase understanding on challenges and potential solutions. And I really hope that I will hear soon from you with questions, but also with informations about your successful projects and innovations. And of course, Mindspace, the whole team, all students, everybody, thank you for this opportunity, and count on my support in the future at any time you need. If I have expertise that I can provide to you, I'm very willing to do it. Of course, if not, I also want to remind you that I'm part of the network of IEEE Smart Cities ambassadors around the world. Many experts from different fields are also my friends. I can also involve some of them. My expertise is basically telecommunications, the 5G, but also I have a lot of friends from different parts, like big data scientists, who also can help you in creation of your solutions for smart cities. So thank you very much. And
it's been an honor, Mr. Maslovic. Thank you so much.
Thank you. Bye-bye.
Have a wonderful evening. Goodbye.
Bye-bye.